In this video, we'll be focusing on using equations to solve problems. This is based on 7th grade Open Up Unit 6, Lesson 11, and a little bit of 12 as well. So today your goal is to be able to solve story problems by writing and then solving that equation. All right, I have some tips for writing equations for you. First of all, you should start by defining your variable. You need to tell your reader what your variable stands for. What does it mean? I've got a tip. If you read the question in the problem, then your variable is usually going to represent that unknown. Second, you should write an equation that represents the situation. It should match what's happening in the problem. It shouldn't just go straight to the solution of how you solve it. Finally, after you do solve your equation, make sure you answer the original question in words, and then go ahead and check and see if it makes sense. Let's do an example. So Claire ran 4 miles on Monday. Then for the next 6 days, she ran the same distance each day, and she ran a total of 22 miles during the week. How many miles did she run on each of the 6 days? Okay, so I want to think of first what my variable is going to represent. In this question, it asks me how many miles she ran on each of the 6 days. So when I'm writing my variable, I'm going to use x because that's my favorite variable. X is going to represent the number of miles Claire ran per day for those 6 days. Try to be as specific as possible. Second, I'm going to try to write an equation that represents what's going on. So initially she ran 4 miles on Monday. I'm going to put that 4 down in my equation. And then for 6 days, she ran the same distance each day. So think if she ran like 1 mile a day, 6 times 1, 2 miles a day, 6 times 2. You're going to multiply 6 by the number of miles she ran per day. So in algebra, we'll call that 6x, since x is the number of miles she ran per day. She ran those miles Monday, plus she also ran these. So we're going to write an addition symbol, 4 plus 6x. And that gives us our total. So we're going to say equals, and we know from the problem this equals 22. Okay, I'm going to go ahead and solve this by doing the same thing to both sides. Once you have your solution, we know that x equals 3. You want to answer this in words. So what does that x equals 3 mean? Since x is the number of miles that Claire ran per day, this means Claire ran 3 miles per day. Okay, and I might actually write that as Claire ran 3 miles per day, and I'm going to circle that answer because it represents my solution. All right, so example 2, a camping store increases the price of a tent by 25%. A customer then uses a $10 coupon for the tent and pays $152.50. What was the original price of the tent? All right, so good. We get to combine our percent knowledge and our equation knowledge. First of all, I want to define my variable. So it's asking for the original price of the tent. So likely I want my variable, and I'll call it x again, to stand for the original price of the tent. Once I have my variable, I'm going to try to write an equation that goes on and represents what's going on in this problem. So a camping store increased their price of their tent by 25%. All right, we know that the original percentage is always 100%. So if they increase by 25%, they're now paying 125% of that original, or 125% of x. And remember, of means multiply, and we want to write our percent in decimal form or fraction form. So I'm going to write that as 1.25x. Now think about this then. The customer then uses a $10 coupon. When you use a $10 coupon, you're paying less. So we're going to subtract $10. Once that happens, she ends up paying $152.50. So we're going to say equals $152.50. Okay, now I'm going to solve this equation by doing the same thing to both sides. Okay, once I've solved for x, I know that x equals 130. Make sure you answer that in words. So, looks like that means $130. So I'm going to say the tent was originally $130. Right, so this can be tough, but you're going to get good with it as you practice. So just when you're doing this, always ask yourself, did I define my variable? Does my equation represent the situation and not the solution? And also, did I answer in words?